Okay, so we're going to start into the 2.8 notes for solving complex equations. The first set of equations we're going to cover are the ones that have decimals in them. And just like equations with fractions, we want to try to clear them out as early as possible. And the way you want to clear them out, again, just like fractions, is that we want to be able to multiply, right? So that what you're going to multiply by is always going to be some factor of 10. And so it could be like 10 or 100 or 1,000. And that really all depends on how many decimal places, right, each of your values has. Now, so if you take a look at part A, right, we see that the most number of decimal places that each of those values have is 1. Right? And then for us, now remember decimal means fraction of a whole. Right? So if you go 1 decimal place, that means 1/10. So we're going to multiply everything by 10 to get rid of the decimal. All right, so multiplying the left side by 10, 10 times 0.4 is going to give us 4, okay, and 10 times 0.6 gives us 6. 1.3 times 10, 13k. Then 1.2 times 10 will give us 12. Okay, so that's how we can get rid of decimals so that we can move forward in solving this equation for k, right, without having to worry about decimal places. All right, so again, isolating the variable, I'm going to undo operations, and we get k is equal to -2. All right, moving on to part B, we see that the most number of decimal places that any of these numbers has is 2. So that takes our decimal place out to the hundreds place. So to clear out the decimals, we're going to multiply everything by 100. So multiplying the left side by 100, we have 1,813 minus 518x. Multiply the right side by 100, 632x minus 832. All right, so again, clears out the decimals. So now we can just worry about isolating the variable and solving for x. All right, so again, we are undoing operations since the left side and the right side are both simplified. Start moving terms across the equal sign, isolating the variable, solving for x, we get x is equal to 2.3. All right, so we have 3 equations here. I want you to take the time to try to solve each of these 3 equations. And sister, describe what happens and explain what you believe the solution may be. Okay, so again, you're solving part A, B, and C. All right, I'm going to actually start here with part C. All right, so again, solving for the variable, right? Since the left side and the right side are both simplified, we can start moving terms across the equal sign. So again, we're going to undo operations. So you may have possibly subtracted 12 from both sides. Like me, where I got 5v on the left is equal to 2v minus 21. I want to get all my variables to the left side, so I'm going to subtract 2v from both sides, leaving me with 3v, right, equals -21. Divide both sides by 3, v equals -7. Right? Again, when you're solving an equation, the goal is to undo operations to the point where you have the variable by itself. Right? You know you're done when you have the variable equals a number. Then you look at part B. All right, so again, we need to make sure before we start moving anything across equal sign that both sides of the equation are simplified. On the right side, we can distribute the 6 through the parentheses to give us 12y plus 6. Now that both sides are simplified, now we look to move terms across the equal sign. So here, again, I subtracted 6 from both sides. Right? I'm left with 12y equals 12y. Maybe I want to move the y's over to the left, so I'm going to do the opposite. So I'm going to subtract 12y from both sides, and that leaves me with 0 on the left and 0 on the right. All right. Now here's a strange occurrence because we were trying to isolate the variable, trying to solve for y in this equation, and what happened is that the variable went away. All right? So it's pretty tough to solve for y when mathematically the variable that we're trying to solve for went away. Right? Again, 12y minus 12y is 0. All right? And not only that, but I was also left with a 0 on the other side of the equal sign. Left with zeros on both sides. Okay, so we need to be careful, right? Because our answer for y is not 0, right? But there is a solution, or at least there is a way to give an answer for a problem like this. But make sure we all understand that it is not y equals 0. Before we talk about, right, that unique situation in part B, let's also talk about the unique situation that happened in part A. All right, so again, we are trying to isolate the variable, undoing operations. So you may have subtracted 6, like me, on both sides of the equal sign. Then I got w equals w minus 3. Subtract w from both sides to try to get all the variables to one side. And again, just like what happened in part B, my variables went away to 0. But unlike part B, where I had 0 equals 0, here I'm left with 0 equals negative 3. So again, in the process of solving for the variable, my variable went away, and I'm left with this statement. Okay? So again, the answer for w is not 0. You're not going to write down w equals 0. You're not going to write w equals negative 3. Part A and Part B are examples of special cases when you are solving equations. All right, so Part C is your typical occurrence when you're solving an equation, when you're trying to solve for a variable. You know that you found the solution for your equation when you're left with the variable equals a number, right? So clearly there is only one solution for V, and that solution is negative 7. That's the answer. Negative 7 is the solution for this equation. And we talked about how we know. Well, we can take negative 7, plug it back in for V in the equation, and we can do a check, right? This one solution, negative 7, we're going to see does work. All right. The unique situations with part A and B is that the variables that we were trying to solve for in both cases disappeared. Right? So we do not have a solution for y in part B. We do not have a solution for w in part A. And the reason we know that because both variables again disappeared. So what does that say about our solution for y? Well, when you're left with a statement like 0 equals 0, right? 0 equals 0 is a true statement, right? And because it's a true statement and the variables went away, what we're going to answer for part B, in terms of the solution for y is that the solution for y is infinitely many solutions. And you might hear some people say all real numbers. And basically this is saying that you can plug any number in for y and it's going to work, right? So we're talking about doing a check for part C where -7 is the only solution that's going to work. For part B, this is saying that you can plug in any number for y and it's going to check out. With part A, again, the variable disappeared. We're left with a statement that says 0 equals -3. And we know that that is not a true statement. 0 does not equal -3. So in this unique situation in solving for a variable in an equation, and we're left with a statement that is not true, then we are to say that there is no solution for this equation. All right, so the vocabulary here, so the no solution is just like the one for part A, right? And for part B, where we had infinitely many solutions or all real numbers, right? That particular situation is called an identity. All right, so I'll give you some time here to work on example 2 and see if you can find the solution for the variables in each of these parts and to describe your solution. All right, so when you solve for part A, you should get W equals -1/2. So it's clearly a situation where there's only one unique solution. For part B, right, you solve for the variable and you find that the variable disappears. But then you're also left with a statement like 0 equals 2, which we know is not true. Thus, it's telling you that this equation has no solution. Then part C, right, again, solving for the variable. You see that the variable disappears. But then you also notice that you're left with a statement that says 0 equals 0. You're left with a true statement, which means that there are infinitely many solutions for this equation, and this situation is called an identity. Okay? All right, so that's it for today's lesson. Move on then to the 2.8 homework.